Let us find the Fourier transform for the function. Okay. Uh, Here it is the function f of x, which is 1 minus mod x. For mod x is less than or equal to 1 or 0, when it is mod of x is greater than 1. Okay. So let us try to solve this problem. And also reduce this here into pi by 2. Okay. So yeah, Fourier transforms. So f of alpha, which is equal to 1 by root 2 pi integral minus infinity to infinity f of x e to the power of I alpha x dx. So mod x, right? So which is x, uh, which is in between minus and plus 1. So your integral, which will be ranging from minus 1 to 1, f of x, which is 1 minus mod x, right? E to the power of I alpha x dx. So as I can, since mod x is this, right? So we can take two conditions where minus 1, 0, and 1. Okay. So here the function is 1 plus x. Okay. Here the function is um, 1 minus x. Okay. So let us take that. Okay. So as I said, f of alpha 1 by root 2 pi, okay, braces minus 1 to 0, 1 plus x, okay, e to the power of I alpha x dx, plus this is 0 to 1, 1 minus x e to the power of I alpha x dx, close the braces. So which is 1 by root 2 pi. Now integration of this. So if I integrate this using by parts, so I keep 1 plus x, and this is e to the power of I alpha x by I alpha minus, this would be 1, okay. So 2 times of integration, so e to the power of I alpha x by I alpha x whole square, okay. So close the brackets, 0 to 1. Again, same with this. This is 1 minus x. So e to the power of I alpha x divided by I alpha minus, this is minus 1, okay? E to the power of I alpha x by I alpha whole square. This is 0 to 1. Close the curly braces. Fine. So let us move further to simplify it. So f of alpha, which is 1 by root 2 pi, substituting 0. So this is 1 plus 0 into 1 by I alpha minus e to the power 0, which is 1. So this is 1 by I square alpha square. Okay, we are done with 0. Let us put 1 minus 1. So this whole term, first term goes to 0, minus e to the power of minus I alpha by I square alpha square. Okay, so we are done with the with the limits -1 to 0. So let us have a look at the 0 to 1. Okay, so first is 1. So this first term goes to 0. Okay, and plus e to the power of I alpha by I square alpha square minus 1 to 1 by I alpha plus 1 into 1 by I square alpha square. That's the process. So let us try to simplify further quickly. So we get this as 2 by alpha square minus 1 by alpha square and e to the power of I alpha plus e to the power of minus I alpha. So e to the power of I theta plus e to the power of minus I theta is equal to 2 cos theta. So if you look at this, you can write here as cos alpha instead of theta by root 2 pi open braces 2 by alpha square minus 1 by alpha square into 2 cos alpha. Okay, or can further write this as root 2 by pi 1 minus cos alpha divided by alpha square. Fine, we got f of alpha. Now we have considered this. Now using inverse Fourier transform. So inverse Fourier transform formula f of x is equal to 1 by root 2 pi minus infinity to infinity f of alpha, which we already found, which is root 2 by pi into 1 minus cos alpha by alpha square. And it is e to the power of I alpha x into d alpha. Okay. So further you can simplify this. I get root pi multiplied is 1 by pi minus infinity to infinity. This is 1 minus cos alpha divided by alpha square. So this is cos alpha x minus I sin alpha x d alpha. Okay, so let us multiply it taking integral part and the real part. So this is 1 by pi minus infinity to infinity 1 minus cos alpha divided by alpha square uh, into cos alpha x d alpha. This is minus I by pi. Okay, so integral minus infinity to infinity 1 minus cos alpha divided by alpha square sine alpha x d alpha. So we can neglect the second term as it goes to 0. Okay, so let us consider only this. Okay, so your f of x is this. Okay, now if I take pi on the other side, okay, so here f of x is 1 minus x. Okay, considering f of x as 1 minus x, and if you put x as 0, so f of 0 is 1. Okay, so it is pi. Okay, so this is therefore minus infinity to infinity 1 minus cos alpha divided by alpha square. Uh, Here x as 0, so cos 0 is 1. So d alpha, which is equal to pi. Okay, by substituting x is equal to 0 and f of 0 is 1. Okay, we got this. Or further, this is if I consider this as 0 to infinity, it is 2 pi, 2 times. So if I bring it on the right hand side, it is pi by 2. So we got this result. Okay. Now further, now if I consider alpha as t, okay, let us put alpha as t. So if you put alpha as t in the previous one, so 0 to infinity, so it is 1 minus cos t by t square into dt. Yeah. So let us substitute t as 2x here. So x will be t by 2 or dx is equal to dt by 2, right? So let us substitute it, and there is no change in interval, it is same. So it is 1 minus cos 2x divided by, so t square, which is 4x square, okay, into this is dx. Okay, so it is 2 dx. 2 dx dt is 2d dx. Okay. Dx, which is equal to pi by 2. Okay, so now 1 minus cos 2x we can write as 2 sine square x. So integral 0 to infinity. So this is 2 sine square x divided by, this gets cancelled, so it is 2x square dx in pi by 2, or we can write as 0 to infinity sine square x by x square dx is pi by 2. This is the required result. Now let us verify the convolution theorem for the Fourier transform for the function f of x and g of x, which is equal to e to the power of minus x square. So f of x is e to the power of minus x square, and f of e to the power of minus x square is 1 by square root of the Fourier transform of this is 1 by root 2 e to the power of minus alpha square by 4. Again, for g of x, it is e to the power of minus x square. G of e to the power of minus x square is 1 by root 2 e to the power of minus alpha square by 4. Now, f of alpha into g of alpha is equal to 1 by 2 e to the power of minus alpha square by 2. Okay, so let us look into that. F multiplied into g is 1 by root 2 pi minus infinity to infinity f of x minus t g of t dt. Okay. So this is by substituting this here you have x minus t. So it is by root 2 pi minus infinity to infinity e to the power of minus x minus t whole square into g of t, which is e to the power of minus t square. This is dt. Okay. Further, uh, f multiplied g, so that is 1 by root 2 pi minus infinity to infinity e to the power of minus, I can take the powers. Uh, this is x minus t whole square plus t square, right, into dt. So let us have a look at the powers. How do we do it? So quickly solve this. You can take care of this, the powers like this. Okay, so the power becomes, it is 1 by root 2 pi minus infinity to infinity. This is e to the power of minus of x square by 2 plus 2 times t minus x by 2 whole square, and this is dt, or um, f multiplied g 1 by root 2 pi. You can take e to the power of minus x square by 2 minus infinity to infinity e to the power of minus 2 into t minus x by 2 whole square dt. Okay. So further, I can take this as 0, 0, and multiply it into 2. And further, I can simplify f into g is root 2 by pi e to the power of minus x square by 2, 0 to infinity, e to the power of minus 2 into t minus x by 2 whole square into dt. So let us take care of the numerator. So I will take this y as root 2 into t minus x by 2. Okay. So dy will be root 2 dt as t is 0, y is 0. And as t is infinity, y is also at infinity. So there is no change with the uh, limits. So here we can write f multiplied g is equal to root 2 by pi e to the power of x square by 2. This is 0 to infinity. Now this will be dt, which is dy by root. So I can take 1 by root 2 e to the power of minus y square dy. So we know this integration of e to the power of x square dx 0 to infinity is root pi by 2. Okay, so let us substitute it. So further f into g, that is root 2 by pi into 1 by root 2 This is e to the power of x square by 2 multiplied root pi by 2. So I can cancel these. So I get the left is f into g is 1 by 2 e to the power of minus x square by 2. So as you can see that f of alpha g of alpha is equal to the Fourier transform of f into g. Hence, we proved it.